Hey everyone, this is chapter 4 trigonometry, and we are starting with something really simple, which is 4.1, the relationship between the radian and degree, right? Okay, so some basic definitions here. So an angle usually is defined by initial side over here and the terminal side over here. So the intersection of these two sides is going to be the vertex, right? And usually this direction, which is counterclockwise, it can be the positive direction, right? If I am going this direction, this is going to be clockwise, and you're going to count it negative direction. All right, so that's basically a definition of an angle. Here this is center position of an angle, so we can see here the initial side is always has to coincide with the x, and then the terminal side anywhere where it should be, right? Okay, all right, so we talk about this. So depending, since this side over here, the x side, that's going to be the initial side, right? So now if I'm gonna go from this side counterclockwise, that's going to be counted as a positive angle. However, if I'm gonna go clockwise, this is going to be the negative angle, right? Okay, so depend where the terminal side is gonna end relatively to the initial side. All right, so coterminal angles. So what the definition of coterminal angles here is, too simply, whenever you add or subtract the two angles, you're gonna come up to 360 degrees. All right, so in other words, they share the same initial side and the terminal side. All right, so for instance here I can see the angle alpha and beta. If I add them up, alpha plus beta, it can be 360 degrees. All right, on the other side here we can see if I, well, the beta start from here and you're gonna turn one whole turn, all right, and then you're gonna add up another alpha. So we can see here beta minus alpha, it can be 360 degrees. In both scenarios they start with the same initial side and they end up with the same terminal sides, right? All right, so here we come up to the measurement of angle, and this is 1 radian. All right, so what is 1 radian? Basically, if the r here the radius and the radius the same that the angle, and as well the length of the arc. All right, so the arc is starting from here to here. All right, that should be also r. So if these three conditions are satisfied, then the measurement of the theta gonna be 1 radian, 1 rd. All right, so this is the definition of a radian. So now you are familiar with the radian, since you know the angle of the whole circle is going to be equals 2 pi radian. All right, so 2 pi is, by the way, 3.14 and so forth, right? So this is equivalent to 360 degrees, which is come up to, if I have pi in radian, this is going to be equivalent, all right, to 180 degrees. Okay, so again here definition of a radian, and usually whenever you have this in radian, whenever you divide this sector length divided by the r, you should get the theta. All right, so in this case the s, we set it equals to r. So if you do theta is going to be s over r. That's going to turn into r over r. That's going to turn into 1, right? So again, if the s, the sector length, is equal to r, then I'm going to get 1 radian. All right. All right. So this is an illustration of radian basically. So here, what you need to keep in consideration that the radius here, this is r. So this is the arc length, all right? Is not the distance. So by the way, if I had drawn, so this is r over here. All right, so if this is a radius r and this is a radius r and this is the distance r, then I'm gonna get a regular hexagon, all right? However, we are not counting the distance between the 2 points. We are counting the length of the arc, and this is obviously longer than r, all right? So it makes sense that there is something left in the end, right? So it's not going to end up exactly there. So there is something extra there, all right? So it doesn't divide exactly by 6. So you're gonna get 6 radian plus an extra, and we know this extra, right? So again, this extra here, since we have 3.14 is pi, so the extra part is 14 here, and the extra part here 6.28, right? So that's 2 pi. All right, so this is 0.28 extra. All right, so anyways, just keep in mind that pi, it should be in here, and 2 pi's, it should be over here after you make one whole revolution. All right, okay. And here they are the common angles. So we have 2 pi's here. That's the whole revolution. Half a circle is going to be pi. The fourth of a circle is going to be pi over 2. 1/3 of half of the circle, so that's 1/6 of the circle, is going to be pi over 3. And that's going to be only this angle, right? Okay. And again, here, this is pi over 4. That's mean 1/2 of the circle divided by 4, or equivalent to the whole circle divided by 8. So this is, by the way, it can be 2 pi divided by 6. So this is the whole circle divided by 6. This one is pi over 4, half a circle divided by 4, and is equivalent to 2 pi divided by 8 as well, right? And so forth, right? This is pi over 6, only half of the circle divided by 6, and you can consider it as 2 pi, the whole circle divided by 12. So if you simplify it, you're going to become pi over 6. All right. So you need to be familiar with drawing these angles. We will be using drawing more frequent here. And here we get the quadrants and the angles. So if the angle is in the first quadrant here, it's going to be the theta is going to be between 0 and pi over 2. If the angle is on the second quadrant of the circle, it's going to be the angle between pi over 2 and pi. So pi over 2 start from here, and pi end over here, right? And so forth. So the third quadrant is going to be between pi and 3 pi over 2. And over here is going to be between 3 pi over 2 and 2 pi. Okay, so keep in mind, this is how we write it down. So how I'm getting with 3 pi over 2 and so forth. So 1/4 of the circle, which is a right angle here, is pi over 2, right? So that's 1 pi over 2. Now, if I do the double of it, that's going to be 2 pi over 2. If I simplify it, I get pi, all right? If I multiply 3 times, so that's pi over 2 multiplied by 3, that's 3 pi over 2. And obviously here, if it is multiplied by 4, that's going to be 4 times pi over 2, and this is going to be 2 pi after simplification. That's the angle here, right? Okay. Finding the coterminal of an angle. All right. So here they give you the 13 pi over 6, right? And well, they tell you what you're gonna do since it is an application, right? So what you want to do here, so 13 pi over 6. So 13 over 6, obviously that's going to be less than 2, right? So your concern is always, where are you falling? Are you between 0 and 2, 2 and 4, and so forth, right? So what we want to do here, 13 pi over 6. So 13 over 6, it can be 2 point something. So this is 13 over 6. It can be here. So obviously you have this as extra, right? So what you're going to do is you're going to do 13 over 6 pi, and then you take away from it 2 pi, all right? And what you want to do here, you want to get the same denominator, so multiply by 6 and 6, and this is going to turn into 13 pi over 6 minus 12 pi over 6. Since they have the same denominator, that's going to give you pi over 6, and that's going to be the coterminal angle between 0 and 2 pi, right? So there you go. Once you graph it, that's you're going to make the whole revolution plus an extra pi over 6. Let's do B, for instance. So they give you a negative angle, which is minus 2 pi over 3. And obviously here again, we are going with the period of 2, right? So 0, 2, and then 4. And before it's going to be minus 2 and minus 4, right? And what you want to do is you're going to do minus 2 over 3 where you're going to fall. So minus 2 over 3 is going to be 0.6 somewhere here, minus 2 over 3. So what you want to do, you want to add a whole revolution to this, right? So coterminal hours, they have, if you add 2 pi to it, you're going to get you another coterminal, all right? And what you should do this, minus 2 pi over 3 plus 2 pi, and again you get the same denominator, minus 2 pi over 3 plus 2 pi. You can multiply here by 3, divide by 3, so this is going to turn into minus 2 pi over 3 plus 6 pi over 3. Whenever you add them up, you can be a 4 pi over 3. And this is the drawing of it, right? So since this is the original angle going backward, and what we did, we add a whole revolution, which is 2 pi to this, and what we're gonna get this angle, which is a positive angle, right? So usually we look for the coterminal angle within 0 and 2 pi, all right? Okay, so more application. So again, 9 over 4, where you're gonna fall, right? So I know it's not between 0 and 2, right? Do you notice here I ignore the pi, so I just focus on the fraction. So between 0 and 2, and then this is gonna be 9 over 4. It's gonna be 2.14, 0.25, right? So what I want to do, I want to take away 2 pi to bring it back here, right? So that's what you're going to do for A. A is going to be 9 pi over 4 minus 2 pi, and then get the same denominator, 4 and 4. This will turn into 9 pi over 4 minus 8 pi over 4, and this is pi over 4. So the coterminal angle, I know what I'm going to call it. Let's call it theta bar, maybe. And that's going to be pi over 4. Now, for the other one is negative. So negative is going to fall somewhere here, minus 2. So minus 1 over 3. What you want to do, you want to add 2 to it to bring it back here. All right, so let's do the calculation. Minus pi over 3 plus 2 pi. You're always allowed to add 2 pi or take away 2 pi, right? And again, we do the same thing, multiply by 3 and 3 to get the same denominator. So minus pi over 3 plus 6 pi over 3. And this is 5 pi over 3. So the theta bar, the coterminal, it can be 5 pi over 3. Okay, so here after the coterminal angles, we are looking for the complementary angle. So this is almost the same thing, just alpha plus beta, it can be 180 degrees, right? Complementary, it can be flat line. Supplementary, it can be alpha plus beta, it can be equals to 90 degrees, all right? And these angles are not coterminals, right? So this is the schematic of it. So the complementary, whenever you add them up, it can be pi over 2. So alpha plus beta, it can be equals to pi over 2. Remember, pi over 2 is 90 degrees. And the other one, supplementary, whenever you add them up, it can be pi. Pi is 180 degrees, right? All right, so again, what you want to do here, I have you are not supposed here to add or subtract, right? So what you want to do here, for instance, for A, I will call alpha, it can be pi over 6, all right? So if I'm doing the complementary right now, I'm gonna have alpha plus beta, it can be pi over 2, correct? So beta, by consequence, it can be pi over 2 minus alpha. So this is the formula you're going to be using, all right? And if I do this is going to be beta, it's going to be pi over 2 minus the alpha, which is pi over 6. You want to get same denominators. So you might want to multiply this by 3 and 3. And this is going to turn 3 pi over 6 minus pi over 6. This will turn into 2 pi over 6, which is pi over 3. So the complementary for pi over 6 is going to be pi over 3. All right. Now, if I'm going to do the supplementary, again, alpha plus beta is going to be equals to pi. So beta, by consequence, is going to be equals to pi minus alpha, right? So this is the formula I'm going to be using from now on. And if I do this, so beta is going to be pi minus, I'm still in A, right? So pi over 6. And I get to the same denominators. So this is going to be 6 divided by 6. And this is going to be turning to 5 pi over 6. All right. And this is 5 pi over 6. Now, since we have 5 pi over 6 for this one, so again, what you want to do is use one of the formulas. So for B, I'm doing B over here. So this is going to be beta is going to be pi over 2 minus 5 pi over 6 multiplied by 3's. And this is going to turn to 3 pi over 6 minus 5 pi over 6. And this is minus 2 pi over 6, which is the same thing as minus pi over 3. So this is minus pi over 3 here. And for the other one, we do the same thing. So think the other one is, I think, is easier, but anyway. So beta is gonna be pi minus alpha. So this is gonna be pi minus 5 pi over 6, and this is gonna be 6 pi over 6 minus 5 pi over 6, which is gonna turn into pi over 6. And that's basically it, right? Supplementary and complementary over here. Okay, so here we are trying to make the correspondence between degree and radian, right? And you need one of the rules. So over here they are highlighted for you. So either 360 is equal to pi radian, or 180 degrees is going to be pi radian, right? And you can turn it into, basically here, 1 degree going to be pi over 180 radian, or 1 radian going to be 180 over pi degrees. Okay, so to make it simple, suppose I have 24 degree and I want to turn it into radian. I always gonna be multiplying and dividing by pi and 180, but the problem is I don't know which and which is gonna go up, which one is gonna go down. One good way to remember, since I have a degree over here, all right, so do you see a degree over here? So the degree has to cancel out, so the 180 degrees is gonna go here, so the degree as a unit is canceling out, and the radian is gonna go on top. All right, and once you do this, so I just figured out that you can simplify 180 and 24 by 12. So this is going to give you 2 here and 15 here. So this is going to be 2 pi over 15 radian. All right, and the opposite is true as well. So suppose I have pi over 6. So this is in radian, right? So what I want to do, I want to cancel out the radian. So radian is over here, that's going to be pi, and the 180 degrees is going to go here, right? So do you see the radian cancels out, pi and pi cancels out. 180 divided by 6 is going to give you 30 degrees. And there you go. So that's how it works, right? Really, you don't need to remember. It's just a trick here. I think here they wanted to convert these angles. Oh, I think they are already there, right? So yeah, the corresponding is already there. So probably you should be more familiar with this than trying to do the calculation every time. So 45 degrees is pi over 4, 30 degrees is pi over 6, 60 degrees is pi over 3, 90 degrees pi over 2, 2 pi 360, and pi is 180, right? And this is what we were talking about, right? Okay, so do you see how they are canceling the units, right? Let's see if we have a question here. So again, 60 degrees, I want to cancel it, so the 180 is gonna go here on the bottom, and pi in radian is gonna go here, and then simplify this and this, it's gonna be 3, and this is gonna be pi over 3. All right, again, this is you shouldn't do this for this one, right? 60 degrees is pi over 3. You should know it right away. All right, 320, yeah, maybe it's a little tricky, so we're gonna do it. 320 degrees is not well known. 320, what is it? You multiply by pi, divide by 180, put degrees radian here. So 320 what can I cancel out with 32 and 18? Probably I can divide by, definitely I can divide by 4. So anyways, it can be 320 divided by 180. You can simplify the zeros and pi radian, right? 32 divided by 2, this divided by 2 is going to be a 9, and here it's going to be 16, and that's it, right? You cannot simplify any further. So this is going to be 16 over 9 pi radian, all right? Okay, and this is the other way to simplify again, transformation from radian to degree. Again, this is shouldn't be done. So pi over 6, we know it is 30 degrees, right? This is should be common knowledge. 5 pi over 3, well, again, is not difficult, so you should do it this way: 5 times pi over 3, or pi over 3 is 60, so that's going to be 5 times 60 degrees, and this is going to be 300 degrees. All right. Could you have done it with the other method? Yes. This is 5 pi over 3. So again, the radian, this is in radian here. So you want to do the radian, which is pi here and 180 here. And the pi and the pi cancels out. The unit radian cancels out. So you're going to be 180 divided by 3, which is 60. 60 times 5, 300 degrees. Okay. All right. Application here and the length of an arc. I think we get already the theta is in fact equals to the sector, the length of this arc, divided by r. Well, this is equivalent formula. S is going to be r times theta. All right. So it's the same thing. And for example, if theta is equal to 240 degrees, what you should do, you should start with theta first. It can be equals to 240 degrees. Turn it into radian first. So this is going to be, you're going to multiply it by pi radian here and divide by 180, right? So this is going to be 240 divided by 180 and pi in radian, right? You can cancel out the 0. 24 and 18, they have 6 in common. So you're going to be 4 over 3 pi in radian, right? Now, if you want to know the S is going to be r times theta. So the r is 4, so this is going to be 4 times 4 over 3 pi, and this is going to be 16 over 3 pi. Remember that pi is 314, so 16 over 3 times 3.14. all right. I'm assuming this is a calculator question, so you just have to use the calculator to do it. Actually, I used the calculator and it was 16.75. It's 7466, and you can round it to 16.75, right? And that's it. So in this question here, we have a radius of 27 inches. Find the length of the arc intercept by the center angle of 160 degrees, right? So again, 160 degrees, this is gonna turn into 160 degrees times, you divide it by 180 degrees and multiply by pi in radian, right? So degree and degree cancels out, 0 and 0 cancels out. 16 and 18, you can divide them both by 2. So this is going to be 8 over 9 pi in radian, right? So now the sector S is going to be r times theta, and this is going to be 27 times 8 over 9 pi, right? Here, luckily, we can simplify this too. So this is going to be 3 times 8 times pi, which is 24 pi, all right? So this is in inches, right? Now, if you want to use the calculator, it would be a little better, I guess. So the final answer here is 75.36 inches. Okay, so in this part here on the application, they are introducing the linear speed versus the angular speed. All right, so let's see what is a linear speed. Linear speed, technically you are on the arc. So I have, this is my angle and this is my circle. So you are technically somewhere here, and this is the basically the speed, right? The speed on this arc. So you are bounded to the radius, right? And that's going to be how much time you are spending. I mean, how much time you're going to go from A to B, all right? So that's going to be the length of the whole arc divided by the time, all right? However, the angular or central line, the angular speed is slightly different. So although we still have the same arc and theta, but we are looking for the theta, how long does it take to open up, all right? So do you see it has to go through this progression over here. So that's the speed of the angle opening up. Now, what's the difference between the previous one and now? This one, you're going to tell me, oh, this opened up with theta too. However, this is bounded to the radius. So the radius is fixed. All right, so the S is already calculated, right? However, here, you are not bounded with the radius. I mean, you can have a radius in this part or this part, it doesn't matter. So we are not calculating the length of the arc. We are calculating how fast the angle is opening up, right? So whether you're going to go from A to B here is equivalent to going from A to B here. The same for this one, right? Now, is there any relation between both of them? And the answer is yes, since S equals to theta times r. So the linear speed, I can write it down as S over t, and I can substitute the S by theta times r over t, and you can recognize theta over t here, all right? So the theta over t, that's going to be your W, all right? What we call W here, right? And this one we called V. So in other words, the V is equals to R times W. They are both speeds. One is linear speed, the other one is angular speed, right? So this is going to be W times R, okay? So that's a relationship between both of them. And I hope you make a difference, right? Oh, we already did it here, right? Okay, so in this question here, they are talking about the second hand, right? So the second hand is this one, the long one. And why we need to define whether it's the long one or the short one, because we know the long one is going to make the whole revolution in 1 hour, right? It takes 1 hour to go around the clock. Therefore, we are looking for linear speed here. So we are not interested in the angle. The angle, although it is 2 pi, we are looking for the S. The S for 2 pi is going to be 2 pi r. And that's the circumference of one circle, right? So that's S. it's gonna be 2 times 3.14 and times 10.2. All right, so this is S. Now the time we know is 1 hour, so the time is taken in hour, I guess, right? Or depend what unit you want. All right, so if you want, you can put it in hour or in minutes or seconds. So either you're gonna make it 1 hour, or either you're gonna make it equals to 60 minutes, right? So let me calculate. Okay, so after calculating the S, which is 64.056, and that's gonna be centimeters, right? So if I'm looking for V gonna be S divided by T, all right? And S is gonna be 64.056 over 1 hour. So this is 64.056 centimeters per hour, all right? Now if you want to do the 64.056 divided by centimeters again, divided by 60 minutes, this is going to be equivalent to 1.0676, and the unit here is going to be centimeters and per minute. All right, so you can express it either ways. Both of them are correct as long as you keep the units, right? Okay, so we have very similar question here. So find the angular speed. So A, they want the angular speed, and then find the linear speed, right? So the angular speed here, we know the turbine blades are 116 feet long, and the propeller rotates 15 revolution per minute, right? Okay, so if I am doing A, the omega, which is the angular speed, this is going to be the theta divided by the time, right? So theta, that's going to be 2 pi, that's 1 revolution, times 15 revolution divided by 1 minute. So on top it can be radian, right? And just plug it in, and that's going to be, and that is equal to 94.2 radian per minute. All right, so that's your angular speed. Now if you want a linear speed for B, the V, remember we have a relationship is omega times R equals to V. So that's all what you need to do. Just take omega, which is 94.2 radian per minute, and multiplied by the length of the blade, which is R, times 116 feet. All right, so this should give you $10,927.2 feet per minute. All right, remember whenever you multiply these two here, that's going to give you the angle times the length, which is R, that's going to be S. All right, S, the unit of S is in feet. All right, and that's it. That's another one, right? Okay, in the last section of the application, we are dealing with the area of a sector, right? The area of a sector is given by A equals to 1/2 r squared times theta. And you notice here, if theta equals to the 2 pi, this formula, the area is going to be 1/2 r squared times 2 pi, right? You can cancel out this, and this is going to be pi r squared. I hope you recognize this. This is the area of a whole circle, right? So it does make sense, right? So we get it from proportion again, right? And this is an application, so they give you, this is 120 degrees and this is 70 feet. So the area of a sector is going to be 1/2 theta times r squared. And again, theta is 120 degrees. Remember, 120 degrees is 60 plus 60. What we say 60 is pi over 3. So I don't need to do the equivalent. So theta is going to be 2 pi over 3. So the area is going to be 1/2 times 2 pi over 3 times the 70 squared. All right. I can cancel out this and this. 70 squared is going to be 4900. So it's going to be pi over 3 4900. Yeah, again, you need to use a calculator here. So let me try it. Okay, just plug it into the calculator, and the answer was 5128.76 feet square. And I think that's the last question, right? That's all.